Okay, so on this video, we're going to talk about one way to solve 2 by 3 linear systems. And that way we're going to talk about in the video today uh, is by using graphing. Okay, so really all we're looking for is, so if I have two functions, right, so y equals x plus 1, let's say looks like this, negative x plus 4 looks something like this, right? The values of x and y that satisfy the system, right, is basically just asking where do they intersect. That's kind of like saying where do these two functions agree with one another, right? So what values of x and y satisfy these systems, right? So it's simple enough. Your calculator can do it. Your calculator can do it in a number of ways, but just by graphing, that's what we're going to look at in this video. So looking at this first system, we have y is equal to x plus 1 as our first system. So I'm just going to put x plus 1 here. So f equals x plus 1. And then the next one, negative x plus 4. So negative x plus 4. And I go ahead and run it, and we see they intersect pretty close to the picture that I drew, actually. Kind of proud of myself. But anyway, so what I'm going to do is just hit menu, and I'm going to go here to analyze graph, so 6, and then I'm going to go to intersection. And then I have to drag the area so I can see with my human brain where they intersect, but I have to tell the calculator where to look. So it looked in that gray area that I just had it scan, and it gives me the solution 1.5 by 2.5. So the answer to my solution, or my bad, the answer to my system would be 1.5 by 2.5. Now, what that means is whenever x is 1.5, y is 2.5, and that's true for both of these. Okay, so if I take the first equation, for example, so y is 2.5 equals x, 1.5 plus 1. Well, duh, I can see plain as day that that's going to be true. If I try it here on this second equation, right, I again have 2.5 is equal to negative x plus 4. And again, I know that this is going to add up to 2.5 as well, right? So it satisfies both of those. So those are values of x and y where both of those functions, quote unquote, agree with one another, right? So let's look at this next one. Okay, and again, just going to use the calculator. Okay, so come back here. So I'm going to hit the tab button, and I need to just delete all of this nonsense. So I'm going to do 2x plus 5. And down here, I like how it just didn't delete what I told it to delete, is just 2x. Hit enter. Oh, well, what does this mean? Well, what it means, if you haven't already guessed, these two have the same slope of positive 2. So that means they are perfectly parallel to one another and will never, ever, ever intersect. So we would say they have no solution. Okay, and this is because, well, if they're never going to intersect, there's no value of x nor y where both of these two agree the same way that this first one did. Okay, so pretty straightforward. Be on the lookout for that. That is going to happen. And it'll save you a lot of time, right? If we had just seen in the beginning, oh, these two have the same slope, they're not going to intersect, we would have realized. Okay, this next one. So let's throw this into our handy dandy calculator now. So might as well put in the second one. Okay, so can't enter that one in just yet because to enter our calculators, we have to have it in slope-intercept form, y equals mx plus b, right? So basically I need to get y by itself. So the way that I'm going to do that here is simply divide everything by 2, and we get y equals 1 plus 2x, right? 2 divided by 2 is 1. 4 divided by 2 is 2. Okay, and then just switch some things around. So that's really just 2x plus 1. And then we see, well, that's kind of weird. So we see that this function and this function are identical, right? So what does that mean? Well, to get an idea, let's look at Desmos instead. It'll give us a quicker visual, I think. But it's pretty straightforward what it's going to mean. You think it's just how do we put it into words? So if I go ahead and say 2x plus 1 and 2x plus 1 again, well, we see that they overlap one another. So going back to how our solutions happen graphically, right? It's where they intersect. So if they perfectly overlap one another, meaning they're the exact same thing like they are here, that means that there's an infinite number of solutions. Okay, there's an infinite number of solutions because they intersect at an infinite number of points. They just continue and continue and continue intersecting. So any given pair of x and y will satisfy this particular system. Okay, so that does it for this video as far as 2x3 systems and solving them with graphing. If you have any questions over this, you know where to find me or shoot me an email. Goodbye.